Hi everyone. So today we're going to talk about section 1.4, which is on angles. So before we get started, if you guys could just take out your interactive notebooks and open to this page, and then we'll get started once you're there. So the first thing we're going to talk about with angles is kind of the breakdown of angles and how they're made up and what creates an actual angle. So our first fill-in is going to be an angle is formed by two rays with a common endpoint. So here, this is an example of an angle. Notice how I have ray BA and ray BC, and those connect at that same point, which would make it an angle, and those two rays have that common endpoint of B. Now, we don't refer to it as the common endpoint. We'll refer to the common endpoint as the vertex of the angle. So that point where they meet would be called the vertex. And then the rays themselves are called the legs of the angle. Now, you can name an angle using 3 letters. So you must use 3 letters. And most importantly, the middle letter must always represent the vertex. So we have to use that middle letter as the vertex. So here, I can name this angle ABC, and I can name this angle CBA. I cannot name this angle ACB or angle CAB. If you think about it, the way that I always tell people to think about it is think about tracing that angle. You'd have to start at the end and go across, right? So I could do ABC, which was this first one, or I could do CBA, which is this second angle. Now I cannot do CAB because if I went from C to A and then home to B, that didn't trace the angle. So I have to follow that natural outline the angle creates. And then you can use a single letter if there's only one angle located at the vertex. So here I only have this one angle, so I can also refer to it as angle B, and that single letter has to be the vertex. And then when referring to the measure of an angle, we want to use the lowercase m. So in this first example, I would say the measure of angle B is 60 degrees. So that little m represents measure. We don't write out the word measure, we just put a little m, and then angle B equals 60 degrees. And measures are always done in degrees. So like when you're walking, you can walk a certain number of feet or a certain number of miles. This is always done in degrees. So that's just a little background on angles. Again, I always like to front load some of those definitions that you might need sometimes, but now we're going to get into the nitty-gritty of angles. So the first thing that we're going to talk about is the types of angles. So there's 4 types of angles. This might be a little bit familiar from middle school because you did learn some of this in the geometry that's in middle school. So the first type of angle that we have is an acute angle. And an acute angle is going to be less than 90 degrees. So it's any degrees under 90 degrees. Our next angle is going to be an obtuse angle, and this is everything greater than 90 degrees. So obtuse is everything bigger than 90, acute is everything less than 90. One way that you can remember this is that acute with an A comes first in the alphabet, so this represents the lower numbers, the numbers under 90, and O comes later in the alphabet, and this would be everything greater than 90, all the higher numbers. And then very particular, we also have a right angle. Now a right angle is exactly 90 degrees and 90 degrees only. So if I have an angle that's 90 degrees, that would be a right angle. If that angle was 90.2 degrees, that's now an obtuse angle. If it's 89.9 degrees, that's an acute angle. Only exactly 90 degrees represents a right angle. And then last but not least, we have a straight angle. Now a straight angle looks just like a line, right? These rays go in opposite directions, so that actually creates a line. It extends forever to the left and it extends forever to the right. And a straight angle is exactly 180 degrees. So if it's 179.9, that is not a straight angle, that would be obtuse. But if it's exactly 180, that would be a straight angle. So those are our formal definitions for this section. So now we're going to go through some examples. We're going to practice naming the angles, classifying the angles, and all that kind of stuff. So the first thing we're going to talk about is example 1. So I want to name the vertex of the angle. So remember, that vertex is always in the middle. It's that middle point that kind of creates the corner of that angle. So this would be K. That creates the corner of the angle. Now I want to name the sides of the angle, or the legs of the angle. So that's going to be 2 rays. Now remember, when we name rays, we have to start with the endpoint. So I'm starting with K and going to J. That would be ray, K, J. You can type out ray, or you could use this symbol if you were physically writing. And then again, same thing, I'm starting at the endpoint and going off in the other direction, and that would be ray, KL. So remember, that endpoint has to come first. Now I want to talk about 3 ways to name the angle. So again, you always want to focus on like tracing that angle. If you can trace it and it is outlining the angle perfectly, then that's a name. So here I can trace it like this. And I started at K, I started at J, went to K, ended at L. So I can name that using angle JKL. I can do the same thing by tracing the other way. So I can start at L, go to K, and end at J. So I can name this angle LKJ. In both examples, it's important to note that the vertex is in the middle, right? That's important. That has to happen. And then finally, I can also name this angle by just naming it by its vertex, because there's only one angle here. So I can just say angle K. And then last but not least, I want to classify the angle. So very easy, there's no box, and it's not a straight line, so it's not going to be right or straight. So now I'm between acute or obtuse. Now looking at this, even though it's kind of flipped down, it still looks like it's bigger than 90. So this is going to be an obtuse angle. And that's example 1. For example 2, same kind of concept here. So again, I want to start by naming the vertex of the angle. So that's that corner. The vertex is the corner. So the corner here is going to be S. Now I want to name the sides of the angle. So you always have to start with that corner and extend out. So that would be ray, SR, and then I can extend out again, and that would be ray, ST. Those are my sides. You can say the word ray, or you can put this symbol. Does not matter. 3 ways to name the angle. Again, I can trace that angle. That's a way to name it. So I can do angle RST. I can do angle TSR. And since that angle is by itself, I can also just say angle S. And now I want to classify this angle. So very important, I can classify this angle in a special way because it's a box. So since I have that box there, this has to be a right angle because that box represents 90 degrees. So anytime you see that little box in the corner, you know that it's a right angle. All right, so these are some basic examples. This is our second to last lesson in section 1.4. There's only one more lesson that comes after this. Once you're ready, you can flip. Now these notes look just like the notes from section 1.2. It's the same kind of concept. So before in section 1.2, we were adding segments together to get the whole segment. Now we're adding angles together to get the whole angle. So this says if D is in the interior of angle ABC, so if it's inside angle ABC, see how it's inside? Then I know that the measure of angle ABT, so this angle here, plus the measure of angle DBC, so this angle here, has to equal that entire angle, the measure of angle ABC. All right, so again, I'm adding my parts and they add together to equal the whole. So I add those two parts on the inside, the pink and the purple, and they add together to equal the whole, which is the blue. Same kind of concept. So you don't have to remember this postulate. Remember, a postulate's just a rule. You don't have to have it memorized or anything. You just kind of have to know how it works. So knowing that two parts add to equal the entire thing. If you and your friend go out to eat and you each have $20, then in total you have $40. Your two parts come together to equal the whole bill or the whole amount you'll use to pay. So we have a couple examples using this. So the directions say solve for the given measures, and then it says use the figure below for exercises 1 and 2. So I'm going to use different colors to delineate between 1 and 2 so that you can refer to it at any time. So if we look at number 1, it says if the measure of angle ABD equals 48 degrees. So angle ABD is here, so that guy is 48 degrees. And the measure of angle DBC, so just tracing that, is 78 degrees. Find the measure of angle ABC. So I know those two small ones, and I want to find this whole thing. In order to do that, you have to add. So I'm going to add 48 and 78 because those are my two parts. So this is a part, this is a part, and we're looking for the whole. Oops, whole. So I have to add my parts together. So I'm going to do 48 plus 78. That gives me 6, carry the 1, 126 degrees. So that whole angle is 126 degrees. So this is the main focus of the rest of today. It's very similar to the segment addition. The next example, so they say the measure of angle DBC is 74 degrees, and the measure of angle ABC, this whole angle, is 119 degrees, and we want to know the measure of angle ABD. So in this example, I'm given a part, I'm given the whole, and I'm looking for a part. So here, if I know the whole thing adds to 119 degrees and one part is 74, in order to find the other part, I have to subtract 119 from 74, and that gives me 45 degrees. So that's the main concept of this lesson. You will have an IXL to do after. The directions are going to be posted in Google Classroom. But I want to go through one more example. This is kind of like your bonus example, number 3. It's the most challenging type that you would see, but that's okay. So for number 3, it says the measure of angle PQR, this whole thing, is 141 degrees. I want to find each measure. So the measure of angle PQR, that whole angle is 141. And this whole time we've been saying one part plus another part adds to equal the whole, right? So my parts, this part and this part, add to give me 141. So that means that 13x plus 4 plus my other part, 10x minus 1, has to equal the whole, which is 141. And from here, I can solve for x the same way we did with Mr. Green last year. So I need to combine like terms first. So I have 13x plus 10x. Those are two like terms. That gives me 23x. And then I have 4 minus 1. So taking that sign with me, and 4 minus 1 is a positive 3 equals 141. Now I'm going to subtract 3, and 23x equals 141 minus 3 is 138. And then divide by 23, and x equals, if we're being honest, I don't even know the answer. Do I have a calculator on here? Where's my calculator? Well, let's find out. Oh, here we go, calculator. So 138, these guys look just like the ones in school, divided by 23, gives me 6. So it goes in 6 times, so x is equal to 6. Now to find the measure of angle PQS and SQR, I have to take that x and plug it back into these guys. So I'm going to now do 13 times 6 plus 4 and 10 times 6 minus 1. So 13 times 6 gives me 78, plus 4 gives me 82, and then 10 times 6 is 60, minus 1 gives me 59. So the measure of angle PQS is 82 degrees, the measure of angle SQR is 59 degrees. All right, and that's the lesson for today. So if you have any questions, please feel free to message me on Remind or send me an email. But other than that, you can close out this video and head to Google Classroom to see what the next steps are for today's assignment. Hope everybody has a good day and an even better weekend.